Matt Hensley at JTech, and in this video we're going to be going over engine performance and what all goes into it. So for starters, we got the fuel system, we got the intake system, we got the ignition system, then you got the exhaust system. And first off, engines need three things to actually be working. And that's going to be fuel, air, compression, and spark. So my bad, that's four things. So you need those four things to get an engine to pretty much just run, and then everything else is just going to come together and get the performance to go right. So in this video we'll be going over the DTCs, diagnostic trouble codes, the fuel ratios. We'll be going over the scan tool and the freeze frame data on the trouble codes. Also be going over the pending, present, and history DTCs and going over the differences between those. So let's get those pulled up. So right here I'm going to go over how to read codes and how to erase them, and then how to look up those freeze frames. So first off, when you erase codes, you just go to erase code. Say yes, yes, and they've been erased. So then you would turn the ignition back on after turning it off. Then you'll go to read codes. And the code right now we have for this one is the ECT sensor, which is, it just picks up how the temperature that the engine's at. So it's engine coolant temperature sensor, and that's going to be a permanent. So that is present right now, and then go to the freeze frame for it. And this is going to show what the car was going through when the DTC came up. As you can see, it's not moving, and that's our problem right there. It's at the hot limit, and that's because it's not working. Gotta find out why. Go down to map sensor. Shows your fuel trims right down here. These are ones, but also the engine's not running when this was pulled up. You got your O2 sensor. Battery is a little bit low. It should be around 12 volts. Got your EGR, which helps control your emissions. So yeah, the freeze frame just goes over what the vehicle was doing at the time that the code came up. And that'll give you a better idea of where to head next. So next step is to find out why that code's being thrown. Just a little bit about fuel ratios. So a good fuel ratio is 14:1. Good ratio is 14:1. So that means 14 parts air, 1 part fuel. So anything less than that is going to be running lean. Anything more than that. So anything less than 14:1, that means you're going to be running rich. Means more fuel than air. Anything more than that means you're going to be running lean, so more air than fuel. And these fuel trim numbers, what that means is, like for right here, it's +1, which means the computer at this time was adding 1.0 parts of fuel to kind of make up for like running lean, but the computer will go back and forth between taking away and adding just for the engine performance. If you get anywhere like +15 fuel trim, then you know something's wrong somewhere and you gotta start looking. But yeah, what the fuel trim means is the computer is either adding or taking away fuel to help the engine run better. And right here, it's adding 1.00 fuel. when this trouble code came up. Alright, so I'm just going to let you know the difference between like pending, current, and history DTCs. And for starters, pending, that means that the computer has seen a fault, but it's seeing if it comes back before it flips on that light. So your light's not going to be on for a pending fault. And then current, you're going to have the fault currently present, and that's when you're going to have that check engine light being on. And that's pretty much the computer saying that there's something wrong. Look into it. And next one you got history, and then that one's going to be when a fault was detected, but it has since disappeared or been fixed. But the computer will put that into its history file. That way, if you need to, you can go back and look at it for reference and everything. But that's another one that your check engine light is not going to be on for. And you use the scan tool to find all three of these, but the only one that's going to have your check engine light on is going to be a current. So on this Silverado, it's a return fuel system. You can tell by those two fuel lines going right there from the engine to the fuel tank. And then this throttle body right here, it's going to be drive-by-wire. You can tell that by there's just these wires right here to control it. And it's going to be controlled by the computer when you push on the pedal. And the drive-by-wire is going to be controlled directly by the driver from the pedal. And I'll show you that real quick. Alright, so that drive-by cable is going to be right here. So you got your throttle body right here. You got the throttle cables all right here. So these will be pulled to open up the throttle directly by the driver. And then this is also going to be a returnless fuel system. And you can tell by just this one fuel line with the red lettering on it. So if you only have one that goes back to the fuel tank, it's a returnless. And if you got two going back to the fuel tank, it's a return fuel system. So right here we're looking at the live data for the throttle position sensor, and that spike right there is from us opening the throttle. And that was held open, and there's your snap right there. So this will just show you the live data what the sensor is sending, and from the looks of it, this sensor is good. So again, you got your held open and then your snaps right there. So this helps in trying to diagnose a bad sensor. That way you get your live data through this scope right here. Alright, so for our diagnostic test, we're checking up on that DTC we found that was being thrown by our car here. And the one being thrown is for the engine coolant temp sensor saying low voltage. So we got the scan tool out just to confirm it, and we have confirmed it because if you look at the ECT temp right there, the voltage is 0.02. That's way lower than it needs to be. It needs to be somewhere around like 4. It's got a 5-volt reference coming from the computer, and then the degree up under it is red based on how many volts are going through it, so based on the resistance. And this one is saying our engine's at 407 degrees, and it's not. So we know definitely that there's a short to ground somewhere. If it was open, it'd be the opposite. It'd be showing over 5 volts and showing low degrees. So we know this is a short ground, so now we gotta try to find it and fix it. So if you remember, before it was reading like 0.02 volts and somewhere around 405 degrees. So we checked to see if it was internal short, so we unplugged it, and when we did, it went back up to the 5-volt reference and then a negative 45 degree, which means that now it's open, but it confirmed that we had an internal short in the sensor itself. We did pull the sensor out and we tested the resistance on it. Resistance was about 30 ohms when it should be a lot higher than that. So that tells us we have a bad sensor, so if we replace that sensor, everything should be working.